Finally, computer vision. This is a set of algorithms that allow machines to see, quote unquote, and interpret images and video. What it does is that the inputs are the images, but the images are seen by the model as pixels. Like this image, you can divide it into columns like this and into rows like this. And if you do that millions of times, you can get to the most narrow units of this image. And mathematically, you can represent it as a huge matrix of pixels, and each pixel is a color. And then the computer vision algorithms make sense of those pixels because they find patterns between, oh, if this color gray here is in all this section, this must be the street. And look at this white here. This must be some painting on the street. And then by looking at patterns of changes of color in this person, it's like, oh, here's a person. This picture is of an object detection algorithm. It's doing supervised learning. It's doing classification because it's finding patterns in the in the image and then putting a label on it because it was trained on other images where some people took the time to add labels to the image. So the model was trained to understand how to identify a person, how to identify a bicycle, and this powers things like self-driving car technology. Much like NLP, before the advent of like ChatGPT and its release, there used to be classic tasks of computer vision, and you would have developers, data scientists making specific applications of computer vision for things like this, like object detection for a company, like, for example, for their security camera to identify a potential theft. And there are things like optical character recognition, which is to get a scan of a PDF and then to try to identify within the PDF what is the, let's say if it's a bill, what is the transaction date, what is the amount of the bill, and etc., in order to help companies convert physical PDFs into more structured data that they can store in a database for all their bills. And it powers things like face unlock on phones, like medical imaging diagnostics. For example, if you train a model on X-ray scans for lungs, and you have a doctor label those scans with here is a tumor, you might train a model where you give it new scans of X-rays, and the model might tell you like, hey, I think there's a tumor here. So that is supervised learning because it's trying to classify there is a tumor there or not, and where is it, but applied to unstructured data, which is the X-ray image, not to structured data, which would fit in an Excel table. How can you fit an X-ray image into an Excel table? So that's all for today's presentation. This is the very basics and fundamentals of machine learning taxonomy. If anyone here has studied data science, they would know all of this already. So thank you for staying until the end anyway. And I hope that if you not studied data science before, that you found all of this useful and that it helps you shape your thoughts and understanding when you hear about the potential use cases of AI for your customers.